Okay, outliers. This is a very, very big topic in statistics, because if I'm doing a statistical study and I get some results and I look at them, and say I surveyed 100 people, and there's one out of those 100 people that is completely way different than the rest of the people that I surveyed, there might be a special situation going on. There's a number of things that could have happened. Possibly the person has a special situation or scenario going on. It's possible that that person actually didn't even care, so they gave me some crazy result just to try to mess me up as the researcher. So we need to identify situations where things like that are happening. Because it's hard to draw generalizations or to really use our statistics to come up with some results or conclusions. It's really tough to do that if we have a data point that's really messing up all of our numbers in our study. So what we need to do is we need to check for outliers. We need to find them. So the first thing we need to do is find the IQR. The IQR stands for interquartile range. Once we find it, and I will make a note of that right here, by the way, it was mentioned in a previous video. However, the way that we find the IQR is we basically need to figure out how far separated are Q3 and Q1. So we're just going to be subtracting two numbers to find the IQR. It'll be Q3 minus Q1. And once we find the IQR, we are going to multiply that by 1.5. And this is just kind of a basic statistical calculation. There are other formulas, more sophisticated things if you get further into statistics. But our scenario is we're just going to do 1.5 times IQR. What we'll need to do is we'll need to look at that. And see, do we have any data points that are more spread out than that? And it will make more sense here when I do this example. So what we have here is, here's our 5-number summary from the baseball celery problem that we did. And if you remember what that looked like, and I'm just going to draw a quick sketch here. We had a little tiny whisker, and we had little tiny boxes. Everything was kind of crammed together here. And then this stretched way out to the 14.1 million salary. And you can put the dashes on the ends if you want. You don't have to. But the key is, and we're trying to realize or figure out, is 14.1 really considered statistically an outlier? Isn't so far out there it's going to really throw off my data and my understanding of what's going on. And so the process we follow to do that is to take a look at the 5-number summary. And the first step, again, is to find the IQR. So if you remember from the last slide, the way you find IQR is you subtract these numbers right here. We need to find the IQR, and the way that we do that is we take Q3 and we subtract Q1. Okay, Q3 minus Q1. And in this problem, the Q3 minus the Q1, I'm going to have 3.05 take away 1. So that is going to be 2.05. The next step there, once we have that IQR, the next step is to take that number, the IQR, I'll write that down here. Remember, the next step was to go 1.5 times the IQR. So what I need to calculate is, what is 1.5 times 2.05? And the calculator is beneficial, and the answer is 3.075. All right, once I have that number, this is kind of the key number. That number is the number I'm going to use, and I'm going to go back to the box plot, and I'm going to pretend, or imagine, if you will, that we are standing on the edge of the boxes. Okay, this edge and this edge. Okay, remember what those numbers are? Those are Q1 here and Q3 here. So Q1 was the number 1, and Q3 was the number 3.05. Okay, so what we need to do is we need to pretend like we're standing here on these lines, and we need to look off into the distance. If we're at 3.05, we're going to look off to the right. If we're at 1, we're going to look off to the left. And the question is there anything further than this 3.075. Is there anything further than that? Because anything further than that is statistically called an outlier. So what I do here is I do this. I'll take, if you want a mathematical kind of formula, is we'll take Q1, which is the smaller one, remember, and we're going to subtract the number that we just found, 3.075. So Q1, again, was the number 1. I'm going to subtract 3.075. And what I'll get there is negative 2.075. So I get negative 2.075. And what I need to check is do I have any data points smaller than this? Well, no, I don't, because I don't have any negative numbers. So what I've done is I've looked to the left, 3.075, and I'm checking, is there anything farther than that? And the answer is no. Okay, I tested it on the low end. Now I need to test on the high end. So I need to take Q3. This time I need to add 3.075. And Q3 was 3.05. And I will need to add that 3.075. And again, you'll want a calculator handy for a lot of these, especially when you get decimal answers and things like that. And you'll get answer 6.125. So what we need to do is we need to go back to our Q3 in our box plot, and we need to look out from the 3.05. And we look out and we need to stop at this 6.125. 6.125, because it says anything further than that, it would be considered an outlier. And in our data, we did have numbers that were more than 6.125. In fact, it looks like we had just one number here. It was just the 14.1. That 5.5, it looks like it was close, but not quite. So this 14.1, apologize, I'll circle it a little bit better. 14.1 is an outlier. So I go back to my data set, and anything over this 6.125 is called an outlier. The only thing I have as an outlier right now is the 14.1. So 14.1 is an outlier. Once you find an outlier, that means you have a data point that is going to really, really throw off some of your statistics when you calculate mathematically. And what we do with outliers is what we need to do is take them out of our data. I need to remove the 14.1 from my data, and I do need to go back and recalculate all of these numbers, the min, the Q1, the median, the Q3, the max, and I need to redraw. I could redraw my box plot, but the key is I need to remove that 14.1 before I really talk about mean, median, and mode. Otherwise, that 14.1 may really, really throw off some numbers and kind of deceive